Okay, so continuing right on. So collect terms a bit. The e to the z squareds cancel, and you're left with just 4z squared minus 2, which is what we got before, but you can't see it's on an earlier session. That was what we got before for H2. Right, so for H3, that's as far as I go. You're supposed to go to H4 and H5, but it gets more and more tedious. You'll have got the method. You can do it yourselves if you're doing. If you're doing the homeworks. Still not quite used to this new board, and it's new habits. Sort of used to standing up. All right. So for H3, here's what your term will be using the second method. So now you're differentiating 3 times here. So this is the same thing as differentiating twice, and I've just put the result here we've done it several times already, right? So this is a result of d by dz of e to the minus z squared. So you got this here, right? So this is just d by dz differentiating this, and if you differentiate that, so you differentiation of product again, as in calculus. So if you differentiate that first, you get minus 2, and then differentiate this. Well, there it is yet again. So the 4th or 5th time, right? So 2z e to the minus z squared. Now collect terms a bit. So this will become 4z squared here, and minus 2. All right. Now so you've got to differentiate this again. So again, a product, differentiating a product. So differentiate this part first, so you get 8z times this, and then 4z squared, and differentiate this again. Here it is yet again. Okay. And differentiate this yet again, right? So, okay, collect terms. So the e to the z squared, e to the minus z squared, all those, so they all cancel out, right? So you're just left with minus 8z, and you got a minus and a minus here, so that's plus 8z cubed, and a plus, minus, so that's plus, and minus, so you got a minus 4z here. So rewriting that, so you get 8z cubed minus 12z, 8z cubed minus 12z. So that's your ME polynomial for your third, your H3. Now you can't see it, but I'm just checking. What did we get last time? The other way, we got 8z cubed minus 12z, which is the same. All right. Then I just put etc. If you're going to go h to the 4th, you're going to differentiate 4 times. H to the 5th, you can differentiate 5 times. You get this result popping up a lot, so a bit tedious. So I'll leave that to you. Okay. Well, that's the first question. All right. Now using this generator formula, what we did in the first part of the previous question, which was question 4, by the way, in the text, and this is now question 5 in the text. So you're asked to differentiate this expression, firstly with respect to z, and secondly with respect to s, and derive some expressions, a term. So you're asked. So if you differentiate this with respect to z, and then equate coefficients of powers of s, you're asked to show this. And if you differentiate this with respect to s, you're asked to show this. You get this expression. Okay. And you're asked to, now, and therefore, note this therefore sign. So given this and this, you're asked to show or derive Hermite's or Hermite equation, okay, which is this. We did that in the lecture on. So what was the context talking about Hermite? That was simple harmonic oscillator. Yeah, in the context of discussing simple harmonic oscillator. All right. Okay, so take this expression and differentiate both sides by z. Okay. So here, this is the first thing we're asked to find. Well, and you're differentiating with respect to z. So differentiate both sides with respect to z, and I'll get my little stool. That's my little stool. Okay. So differentiate both sides with respect to z. So here you're differentiating the left-hand side, and that gives you this result. Okay, which is 2s times this, but this here is this, right? From the generating function. So we can rewrite this as the sum of, okay? All right, now differentiate the right-hand side. You just keep that on the back burner for a while. And now differentiate the right-hand side with respect to z, and you just get dh by dz, right? Because it's s is not z. All right. Okay. So this and this have to be equal. Okay. Because they started off equal. If you differentiate both of them with respect to z's, you get the same. Right. So these two have to be equal. Right, now let's have a look at the coefficients of powers of n. So let's have a look at the two coefficients, left-hand side and right-hand side, of s to the power n. Okay, so let's have a look at the coefficient of s to the n. Here's s to the n, so you got divided by n factorial dh n dz. So here. Now on the right hand side, now you're summing over all n's, okay? And we want